Good afternoon, Paz.
Hi, afternoon, sir.
You good?
Yes, sir.
Good, good. All right, I'm just waiting on others to come in, yeah?
Yeah, I just asked about him.
Okay. All
See
right,
what
good.
Michael.
Thanks.
Oh, Michael same soon, Jen.
All right, then, no problem.
Good afternoon, sir. Good evening.
Yeah, man, Michael, evening.
Yes, yes, Mikey. How you doing?
Oh, good, good. Yeah, check to save this thing hour.
Uh-huh. Um, it's just the pair of you.
Cool. Yeah.
Um, and it's now 23 past, so I'm gonna give no more than 7 more minutes, and then I will begin. But I think what happened.
Okay, sir, no problem.
Oh, cool.
Good evening, everyone.
Evening, Hazel.
Good afternoon, Asia. It's not 6 o'clock. Sir, everyone is here now.
So, I'm gonna ask a question. Carol, can you unmute for me, please?
Yes, sir. Good evening, sir.
No, good afternoon.
Good afternoon.
So you can come on and say good afternoon when or you just come on and say it. I mean, about your which one?
Repeat, sir.
Now I'm just asking. When you came on a while ago, you said good afternoon to those that are here.
No, sir, I did not.
Oh man. All right, good. So all right, thanks. All right. You can mute. Okay, colleagues. Good afternoon to you. There are some basic online etiquette that we have to start practicing because when you go out after this semester as graduates of Excelsior Community College and you're into your Zoom meetings, once you come on and see somebody, you must acknowledge them because you came on and it's just like you going into a room and see someone into the room. You must, good etiquette, good manners, say to you that you must say good afternoon, good morning, good evening, whatever the situation is. You can't just come in and just sit down so and you're not vexed with the world. I saw it the other day, Monday, I think. Not Monday, Tuesday, whichever day. And I'm now seeing it tonight again, or this afternoon again. So please, come next class, God's willing. I don't want to see it. When I came on and I saw Paz, did I greet you, Paz?
Oh, yes, sir.
Yeah, man, it's common etiquette that you have to practice. When you go out there, following this semester, they're going to say, then how him get bachelor's degree, then how she get bachelor's. You don't want to leave that sort of impression upon people. All right. So please, something that I'm going to be watching. Um, because you must learn that. It's not just to come to school and get your education. There are some basic things that must be learned. All right. With that said, I trust that today was a good day for you. I trust that you are ready to learn. Um, I have yet another conversation to have with you. No, this is me, um, touching actual base with the curriculum. Last class, I was just giving you a little, feel of what the course is. Now it is that I'm getting to the specificity of what it is and what it entails. So I'm going to ask for your 100% participation and involvement. I don't want to hear one person alone talk. I want to hear a conversation between and among us. So where am I going to start? In a minute anymore. I'm going to be looking at the particulate nature of matter. I'm going to look at the particulate nature of matter. And I'm going to uh, and I'm going to um do start off with matter. What is matter? Anybody know what matter? And please don't tell me what is in the eye. What is matter? Anybody knows what matter is? I know you know that a few of you told me that you never did chemistry before, but anybody has an idea what matter is? Matter.
Sir, my understanding of matter is like
Mhm.
any mass that occupies like space.
Good. Good.
For me, it would be like a particle.
Okay.
Anything that take up space like this.
Okay. All right. Anybody else?
Sir, I would add to what Paz and Michael said to say that matter is anything that has mass and takes up space.
Anything that has mass and takes up space. All right. Good job. Let me share this to document with you. So I appreciate what it is that you three have contributed. So matter is anything that is made up of anything that has weight and takes up space, such as air, dust, um, an eraser for argument's sake, a tabletop, etc. And then now I can tell you that I have 3 states of matter, and they are solid, they are liquids, and they are gases. So I have those 3 states: solid, liquids, and gases. All right. Now, if you were to look at it, I have 3 different macroscopic view on screen, and I'm saying to you that solids, liquid, and gases are all made up of macroscopic particles. You're not going to see them, but you know that they are there. So when you look at a drop of water from the pipe, you're not going to see the you're not going to see the particles in the water, but you know that the water molecule contains. Anybody knows what formulation has water? What 2 compounds make up the water molecule?
Hydrogen and
Hydrogen and oxygen.
Very good. So when you look at a drop of water, you're not going to see hydrogen atoms and oxygen atoms, and not going to see the molecule coming together to say it's H2O. Oh no, you ain't going to see that. But you will know that it contains 2 hydrogens and 1 oxygen. So it says the behavior of these particles differ in the 3 phases. Them don't have no behavior. Put it this way: if you ever try to let out a silent fart that is gaseous in and of itself, soon and very soon, everybody will know, say, somebody did something, because it is going to be moving from one region to the next. If you put on cologne and you walk into a room, somebody may say, smells so nice, because definitely you're gonna smell it. If somebody is smoking high grade, you're gonna say, who that man? Because you will know. You're not seeing it. You may see the smoke, but you may see the smoke particles, but you're not seeing the composition of the smoke particles in what it is that you're seeing. But you may see the smoke particles. True or false?
Yes, sir. True.
Yeah, man.
True.
So let us look at the microscopic view of you remember I did say to you that I am unable to, because we're not in a lab sense, I have to be very creative in how I'm presenting some of these stuff. So at least you can have some appreciation of what is happening. So if you look there at the microscopic view of a liquid, you can see that there's some movement. If you compare the movement in the microscopic view of a gas to that of a liquid, what can you see?
The gas
There's
is
less
moving more
particles in the
freely.
gas, and yeah.
Good. I heard that, Carol. Very nice. And Paz is agreeing. The gas is moving more freely than when compared to the liquid. All right. What would you say about the solid?
It's compact and there is no movement.
No, it's still moving.
In the diagram?
Yeah, I still see a little movement.
Oh, yeah.
Yeah, it's moving, but it's
It's not moving. Yeah.
Okay. Something comes to mind. Let me answer that question.
And sir, it's also like more uniform in how the particles are structured.
Right. So in how the particles are arranged.
Yeah.
Okay. Compared to the liquid, what can you say about the arrangement of particles in a liquid?
It's not uniform.
We can say about the gas then. All over the place, don't?
The gas all over the place.
Yeah, man. No behavior. Wild Lego beasts, no behavior. And you're correct. Something came to mind when I listened to Carol contributing just now.
Or is it that matter still, sorry to interrupt, but is it that like matter is continuously moving?
In a solid, it as you said, it is, or somebody said it is fixed, but you're seeing some movement here, so am I. And in this particular case now, what it is that you're experiencing is really vibrational energy, because the particles are fixed. The particles are in a fixed position. So you really won't have any movement up. The particles won't be moving out of position. They're in position. Can you see that?
Yes, sir.
Good. But you will experience what we call vibrational energies. So think of it this way. When you're sitting at church and somebody behind you has their phone on vibrate, and the phone will ring out and ticklish you in your back because you sit down and you feel it. The particles in on that makes up that solid wooden bench. Do you think the particles are moving? What is happening?
The sound from the phone creates the vibration.
Right. So the phone is generating some vibrational energies. So the particles are not moving, but the particles are vibrating. Particles are vibrating, right? And when you compare the liquid now, if you have a bottle of water beside the phone or on the bench, that cell phone is vibrating, what are you going to be seeing in the liquid?
Like waves.
Waves
Right.
or ripples.
Ripples.
Or ripples,
Yeah.
good. And what does that signify?
Transfer
Movement.
of energy.
Right. So you're gonna have vibrational energy again, because it's something is vibrating, don't?
Yes, sir.
You're gonna have rotational energy because the particles are going to rotate. Talk truth. Are these particles rotating?
Yes,
Yes,
sir.
sir.
Yeah, man. The particles going to rotate because you're gonna have rotational energy. What kind of energy you see again? You're gonna have. Let me not tell you what kind of energy you think will happen again.
Kinetic.
Well, there's kinetic energy, because once you have
Yeah.
movement, it's
Kinetic.
kinetic
Yeah.
energy, right? When the body is at rest, it's potential energy. But let me ask you, if you have a fish tank and you tilt the fish tank one way and to lift it off the stand, and then you put it down, what will you see happen?
The water or everything moved to this side that is tilted.
Right? And when you put it down, what happens?
It comes back. No.
Yeah, man, it does. And then when you move off and then you start watch it waiting happen.
It go back and forth, back and forth.
It go back and forth until what?
Until it stays still.
Until it comes to a rest, don't?
Yes.
Yeah.
Yeah.
Good. That we call that translational energy. We call that translational energy. What we call it?
Translational
energy.
Yeah, man. So think of this way. Like California, may Lord be with them, because they're having so many fires going on now. When they have earthquakes, for argument's sake, in California, what you're seeing there, you can see the ripples, you can see the translational energy of the water in the pool moving from side to side. And when it gets to one side, it hits the side of the pool, and then it started to splash. And then you see it move to the other side and start to splash. Anybody can recognize that or envision that or see what is happening there? Imagine what is happening, rather. Hello, somebody? Yeah? No?
From the shaking, yes, sir.
Yeah, man. So that is translational energy. That's translational energy, because it's moving from side to side. So the water molecules is translated. And during that translational energy, you're going to also have rotational energy, because when it's translated, some of the molecules inside are going to rotate. And also,
Yes, sir. Yes, sir.
Yeah, man, and turn over and kin properly on him something there. Mm. All right. In the gaseous state now, what kind of energy do you think it has? Do you think it has vibrational energy?
No, sir. Definitely not.
Why not?
Because it clearly show everything is just one big space and it's just moving
So
very
you don't think
freely.
you don't think it has vibrational energy, it experiences vibrational energy?
Well, to see it, I'm not really seeing the vibration on
Okay.
this plane, so I'm just
And that's
mostly
fine.
seeing it like,
And
yes.
that's fine. So let us have some conversations because you have to be very creative now. Hold on 1 second, please. All right, sorry guys, my system is dying. I'm trying to find my charger here. I'll come in back 2 seconds. All right, guys. Apologize for the break here.
Sir, quick question.
Yes, sir.
So once there is translational energy, you must have rotational energy, or that's not always the case?
So when the particles and in answering your question, good question, but in answering it, I'm gonna pose a question to you and you are gonna answer me. In a solid, do you think you have you asked about rotation?
Yes, sir.
Do you think the particles in a solid, do you think they rotate?
No, sir.
Okay, so what do you say to your answer then?
Not always the case.
Not always the case. So rotational energy does not occur in all of them, because in the solid, the particles are in a fixed position, so they won't be able to rotate because they're in a fixed position, but they'll be able to translate. Not translate, sorry. They need to vibrate. So in the solid, they only experience vibrational energy.
Yes,
You
sir.
follow that?
Yes, sir.
They won't rotate, they won't translate, but they will vibrate. But in the solid, in the liquid now, they rotate, they vibrate, and they also translate. And then in the gases, of course, everything happen right there, so because them just in and out and above. Fair enough?
Yes, sir.
All right, good job. Any other questions? All right, now hear me out. Lots of what is happening in chemistry is you presenting with some information and trying to see how best the information you can digest the information and see how it really happens in real life. All right. There is something else I need to ask you though. What do you think about the shape of the gases? What can you tell me about the shape of gases as we look at the behavior?
That's an indefinite shape.
It has an indefinite shape. Why?
It takes the shape of the container it's in.
It takes the shape of its container, yeah. But very good, it does. But before I move on, I'm just reminded, Carol said something earlier, and it was at that time I asked you to hold on. Carol, what you said again? And I asked you, you said something, and you said definitely not. What was the question? I said definitely not to, please. I needed to correct something.
Sir, I don't remember saying definitely not, but I think it was when you asked if the gases vibrate, and I said based on what I'm seeing, I don't really see any vibration
No,
compared
man,
to the
you did
solid.
you did say definitely not.
I did say
That's
definitely not. Okay.
Yeah, man. And then no, that's what stood out. But I don't have a problem with it, because we are here to learn. So let me ask you a question, all of you, not necessarily Carl. Let me ask all of you a question. When you have so when you're using your say you have a cologne bottle, but the cologne is finished and you have one little tubes and you lean it one side to get one last little spray and nothing happen. And you put it down and it stay right there, so on the dresser top. Do you think the gas particles are at rest, or you think them in motion? You're not touching it, it's there.
Sorry, sir. You can repeat the question for me, please?
So I am asking, what if you have a gas, what if you have hold on one, please. Right. You heard my question, Paz?
Sir, he was asking to repeat.
Okay. So what I'm saying to you is, my question to my scenario is, you have a bottle of cologne, empty bottle cologne, empty bottle, I'm saying empty bottle because when you spray it, you're not getting any juice out of it. Empty bottle of cologne. I'm asking you, do you think the particles are at rest in a bottle or are they still in motion?
They're still in motion.
They're still in motion. Why?
Sir, based
I
on
will explain
how
that why, you know.
gases are, the particles continuously move so at random, so they never really come to a complete rest. I'm not sure.
Okay. All right. I like
Sir.
when it's on. Go ahead, Paz.
All right. So could it be a case where being that the bottle would have air particles and water part, not water part, but like liquid. For the air, it would be constantly in motion, but for the liquid now, once it's resting on a surface, then it would not be moving.
All right. Let me create another scenario to you. And that scenario will answer your question. Say, for example, your dresser is across from a window. And when the sun come in, the sun shine on the bottle. The bottle empty still, you know. You may have one or two droplets of cologne in there. But when I say empty, I mean it is when you spray, you're not getting anything out of it. Right? That's what I mean by empty. But you still can see two droplets or a few droplets of cologne still inside there. Do you think the particles are in motion? The sun has lit the bottle. Do you think the particles are in motion still? Guess your particles that is. Do you think they're in motion?
Yes, sir.
Okay. All right. Why?
Based off of the space.
Hold on a minute, please. Hold on a minute. Sorry about that. Yes. Paz, I'm going to ask you to go back again. You're saying you're answering a question, but I was saying to you, I was asking you another question to say, your what if your dresser is beside a
Oh,
window?
yes, sir, I heard it.
Right.
Yeah.
What do you think is happening? Do you think Carol did answer and say yes, the particles will still move? Let me ask you, do you think that the particles will still move?
All right. So yes, I believe that the particles will still be moving. However, with the sunlight, it will charge the particles and allow for more kinetic energy, so would have more movement.
Excellent. That's the point I'm making. Excellent. So whether or not the particles are at rest, once it is in a gaseous state, you have slight movement. You have slight movement once it is in the gaseous state. So it may not move in a rapid, haphazard motion, but you're going to have movement of the particles nonetheless because it's in a gaseous state. Follow me?
Yes,
Now,
sir.
when you have heat applied to that bottle, um, heat from the sun or from a light bulb, any source of heat at all, it means, as you said, those particles will become charged. And those particles, it's not all of the particles, the gaseous particles, like us in class, you may have some students that are active and some students that are lazy. Hello?
Yes, sir. True, sir.
You will have some particles, gaseous particles, that are lazy and don't want to move. And you have some particles that have ADHD. They're always in motion. But you will have some particles say, you lucky, me I save my energy. But guess what? When those particles become charged, you're going to see it moves in a rapid, haphazard motion, and the particle that is always up and down will bounce into one particle. You notice sometimes, well, I hope this does not happen to you. It has happened to me before. You're driving good, and somebody just run into your back and then it pushed you into somebody's back. I mean, yeah, push you into somebody's back. And then you push somebody else in somebody's back. Yeah, man, that's exactly what happens with the gas particles. So when one particle is up and about, and when the other particle trying to sleep, it move and it bounces into the particle and wake up the particle and make the particle have to move. So you have movement, but when you have heat being applied to it, you're going to have much more movement taking place, and then you're going to have this sort of rapid, non-directional, movement taking place in these particles. So yes, so that's what happens. So the question I was asking is, in a gaseous container, the particles in a container containing gases, the particles of the gas will take the shape of its container. Do you believe that?
Yes, sir.
Absolutely, because the gas particles are moving in a manner that is confined. It's confined. So let me show you something here now. We're looking at some characteristics of gases, liquids, and solids, and the microscopic explanation for their behavior, right? So in a gas, it assumes the shape and volume of its container, and the particles can move past one another. Particles can move past one another. As a matter of fact, the particles can bounce into each other. And when it bounces into each other, they can turn around and say, oh, bounce into me. And it can bounce into somebody else, and it can have this rapid bouncing going on. And then you can have some big fat particles, and when that big fat particle bounce and lick down one little maga one, it'll go drop boof. And while that one drop boof, it can bounce into another particle, and then you can have this sort of movement taking place in the particle, especially if the day is hot. You know what is also true? When you have your cologne bottles on the dresser and it is in the sun, you may accuse me of going into your room and spraying out your cologne. I didn't. But some of the gas particles are escaping because it is so charged, so energized, that it is bombarding against a container and it pushes to the top of the container and some of the gas particles escape because it is way too charged. So you know me put my cologne? We don't know one draw bottom. The sun have for good for go through that, for catch it. So because of that now, I don't have that problem with my cologne taking place. Similar to if you have we call it a fish tank with water in it. And you see the water go down. Is the fish them drinking the water?
No, sir.
Okay, waiting happening.
Let's say it evaporate.
It is evaporating. And you're correct. It is evaporating. It is evaporating. All right. So you know, and so you just have to see the chemistry that is happening inside here. All right. So the liquids also assume the shape of its container that it occupies, and the particles can slide, can move, or the particles can slide over each other. It can move or slide past each other. All right. Hey, waiting we solid up now. What that say?
Retains a fixed volume and
Particles
shape.
locked into place.
Locked, can't move. So I hope that now answers your initial question of me. It is locked into shape. It cannot move. So that's why it only experiences vibrational energy. You follow me?
Yes, sir.
Yeah, man. I want to make sure I understand this, you know. Let us look at the gases now. Compressibility. You can compress one gas?
Yes.
Right.
Before it explodes.
No, but you can. So how you think they get?
In
How
the
you think they get?
tanks?
Very good. How you think they get oxygen in tanks? That's what happens. That's what happens.
Or hydrogen?
Or hydrogen, or helium.
Or cooking gas, LNG.
Or what? Say it again, Mikey.
LNG, liquid.
Oh, the LNG, yeah, the liquid
natural.
natural, yeah, the liquid natural gas. Yeah, man, that's exactly what they do. It is compressed. So what they do, because remember, it's going to be mixed with. Remember, because the gas particles are so far apart and they can move up and down. What you're doing, you're compressing it, so it is that you are reducing the space that these gas particles have, you know, to move up and down. So when you're compressing it, you know, it becomes very dangerous, you know, because remember, you know, pressure bust pipe, don't it?
Yes, sir.
Yes, sir.
Mm-hmm. And when you're compressing that cylinder,
Can create an explosion.
it can create an explosion. So sometimes, so some people say, no, man, put a little bit more gas in there. No, it's all if you have your tires and you decide that it says the PSI is 30 and you decide to put 40, you may be filling it up, and after that, the tire just burst open and fly you, and make you fly gone somewhere. And matter of fact, if there's any splinter in that tire, like broken wires when it is that it was being manufactured or whatever it is, and all of that blows into your eye, you can actually become blind. So when they said to you, for you drivers, the PSI is the pressure for your tires is going to be 30 or 31 or 35 or whatever it is, stick to what it is supposed to be. You try to put more than that, you can have a problem. Good point that just come to mind. You know that you can be in an accident and you don't die from the accident per se, but the airbag can blow and that can kill you.
I never thought about that, sir.
Yes, I. Yeah, man. So it is. So you one has to be very careful because you know we underestimate sometimes. We underestimate sometimes the power of gases. Underestimate it. All right. Now for the liquid, it is not easily compressed because you can't squeeze out. If you have a syringe and you're trying to compress that, you're going to have some spillage. You're going to have some spillage. You're going to have some spillage. And of course, for your solid, it is just definitely almost impossible to compress. Almost impossible to compress, right? Very little space between the particles. Very little space between the particles. All right? Following so far?
Yes, sir. Well, then.
Gases, the flow of gases, remember now, it will flow easily. It will flow easily, right? So the particles can move past each other, but for the liquids, it also flows easily because the particles, again, can move or slide past each other. Do I have any sort of movement in my solids?
No.
No, it is rigid. It is in a fixed position. They are unable to move past each other. Unable to move past each other. Won't happen. Not today or tomorrow. Following so far?
Yes, sir.
Any
Yes, sir.
questions?
Yep.
Any questions?
No, no question.
All right.
Sir, good question. Is there any solid that does not conform to that rule?
All right. So let me qualify that now. So you do have some solids, you see, that say for example, you may have bagasse wood or a bagasse board, which is a solid, don't?
Yes, based on how
Good.
it's made, yeah.
Based on how it's made. Good. But you see, just like what you said, based on how it's made, it is going to be synthetic. So what is going to happen is that you are going to have airspace in those. So if you try to compress
Yeah.
it and put it through something, it can get flatter, true or false.
True.
Yeah, man, because it has airspace inside of it. Now, if you take a piece of wood, naturally, no, wood contains moisture, Do you know that?
Repeat
Yep.
what you just said, sir.
Wood contains moisture.
Yeah, man, Wally.
Absolutely. So that's why when you put a piece of wood out in the sun, it warps.
Yeah.
Because what
Reduce
happens?
inside.
Huh?
It reduces, it shrinks and it flex, it bends.
Right. Because what happens is that the water molecule that makes it very flexible has evaporated. So what you have to do now in order to get it back to its original length without the warp nature of it is to wet the wood. Wet the wood and put some weight on it and leave it for a couple of days and it comes back flat. So what I'm saying to you is that what was I doing the other day? What was I doing? I was climbing an apple tree the other day. Craving. See apple up in a tree and decide, say, yo, I gonna eat one apple today, And I held on to a branch on this so-called solid apple tree. And it's a good thing that it's not just one branch that I held on to. I held on to two separate pieces. Because the one in my left hand left me, and I find myself I go ground. Fortunately, I had to hold on very tight to the other branch that I was holding on to with my right hand in order for me not to hit ground because the tree was hollow. So yes, you can have air spaces in it. Sometimes some wood, is hollow on the inside. It may look good on the outside, but it can be hollow on the inside and you have air spaces and it also contains moisture. So yes, when you compress it, you can actually squeeze it out, which is why it says not easily compressible, little free space between particles. It didn't say no free space. You see that?
Yes, sir.
Little tubes of free space. All right. Any other question? I like the way you guys are thinking though. All right. Now, from the microscopic view and the table that we just went through above, you can see that particles in a gas are well separated with no regular arrangement. Agreed?
Yes, sir, I agree.
Liquids are close together with no regular arrangement, and that the solids are tightly packed, usually in a regular pattern. Let me pause and talk about that regular pattern because I think Michael was the one who mentioned the structuredness of the solid particles. Anybody ever throw rice in a container yet and the container go on like it was full and you have little tubes of rice left in the bag and you want to use it up, you want to put it in the container? What you do?
Sir,
You
not
threw
throw
the
it in the
rest in
same
it.
way.
Who's
You can put
talking
it
now?
in the same way.
Yeah,
No, but
shake the container to look at space.
correct, but when you put it in the container, you know, the container said it's full up to the brim, and you have one little tubes left. Eh? Where does Mikey?
Yeah,
We're
shake
going
the
to add water
container
in
and
it.
look at space.
Hold on, Mikey, hold on. Tyrell, come to the front of the class. You are gonna put water in your rice? You know, Carol can't cook, you know. Carol can't cook. No, Carol, you know, Carol, no, you're not gonna put any water on the rice. All right, no, Carol. All right. Mikey, you're saying something now, though.
No, sir, I was saying, you shake the container and make little space and then add it.
You shake the container.
Yes, you know, make little space.
And when you shake the container, what are you doing?
You're settling out the different rice grains to create space.
Is it that you're settling out the rice grain? What are you doing actually, guys?
Sir,
Oh,
it's
vibrating.
arranging
Come on,
Yeah,
continue, Carol.
vibrating.
Continue.
it
You have
when
to
because I didn't
redeem
really
yourself, you know.
melt it. Yes, sir. When you
Yeah, man.
shake the container, it's setting the rice in a particular way.
Very
So
good.
making space so you can
Very good.
finish add the rest of the rice. I'm redeem myself and I can go.
Yeah, man. Did you have to redeem yourself? Because, girl, when you tell me you're going to put water in there, you know you can't cook. Jesus, help our Lord.
So
Yeah, man.
never did it.
But, yeah, man. So that's correct. So when Mikey said that you're going to hit the container, Mikey, yes, you are now experiencing vibrational energy. So when you hit the container, all the rice grains are now lining themselves up in a particular way so that it is reducing the airspace between the particles. So you recognize now, say it now full to the brim again, and it take time come down, and you can add more. And the more you hit it, is the more you're compacting the rice and the stuff. And it happens with sugar too, because you know that sugar are made up of crystals that are
Yes,
in
sir.
cubic form.
Enough time.
Yeah, man. So in cubic form, so when you do that, you lick it up and you arrange it in order so that, guess what? You are reducing the airspace so you can put more sugar inside of the stuff. So that's exactly what it is that you're doing. You follow me,
So
Paz?
the water could have worked with the sugar still.
Yes,
Oh,
sir,
Jesus.
following.
Michael, go.
Oh, I leave Carl alone, you know. All right. So, and particles and gas vibrate and move freely at high speeds. Liquids vibrate and move about and slide past each other. And you'll recognize that a solid vibrates or jiggle, but generally do not move from one place to another. Right? They do not move from one place to another. And then you will see that liquids and solids are often referred to as condensed phases because the particles are very close to each other. Very close to each other. Them loving. All right? So I'm going to look at another table that will summarize the properties of gases, liquids, and solids. and we're going to identify the microscopic behavior responsible for each of the property. Now, you know that when we take water and put it in a container, it converts to a solid, don't? We put it in a refrigerator, it converts to a solid, don't?
Yes, sir.
Good.
Yes, sir.
All right. So we're talking about a solid here now. So from a solid to a solid to solid transformation. From a solid to a liquid, we have melting, don't it?
Yes, sir.
Somebody may say, sir, solid to solid transformation, nothing can go so. Can anybody think of a solid to solid transformation?
When you say transformation, what do you mean?
The formation of something else.
Well, me, I think about like ice sculptures and them something there.
Okay. Anybody else?
Sir, soft ice to tough ice.
Soft ice, tough ice. Okay. All right. Got you. Anybody else? So from a solid to a liquid, it is known as?
Melting.
Melting.
From a solid to a gas?
Sublimation.
Sublimation. So it moves directly from a solid to a gas. That's sublimation. That's one of the labs we're going to be doing soon. We're going to be doing one of those labs soon and very soon. All right. Now, from a liquid to a solid.
Freezing.
Freezing. And a liquid to a liquid.
Oh.
Not applicable.
Not applicable.
Not applicable.
Yeah, nothing can happen. No, it just can have liquid. Yeah, liquid, right? However, the one that is more dense will do what?
The freezing.
No. The one that is more dense will
Sink.
Will fall to the bottom. Yeah, will sink. Put it this way. And I want what I'm teaching you guys, I want you to see the chemistry right around. If you were to ever and the males may see it a little more than the females, but they should be able to see it in both sexes. If, for example, you don't have much liquid to drink and your urine is a little dark because it says that you need a little bit more water in your system, and you urinate in that toilet, the urine is going to sink to the bottom of it because it becomes more dense. It has lots of things inside of it. So it's going to be more dense than the water that is in the toilet bowl itself. And even if it is not heavily colored, but there's some sort of coloration in the bowl, if you don't flush it immediately, after a while, you will see the urine sink to the bottom. Because remember, we have lots of things that pass through your blood system that gets right. So it's when it sink. No, and think of it, one good way of demonstrating that as a lab and work with me, put some water in a glass. About half fill the glass with water. And then when you half fill the glass with water, you pour some syrup in the water. What do you think will happen?
The syrup
go to the bottom of the glass.
Because it is more dense.
Dense,
it is more dense, yeah. And if you drop some honey in it, what will happen?
The same thing.
The same thing.
That's why you mix it.
Do you know that honey? Do you know that honey is considered a solid, even though it runs?
No, sir.
Because of the thickness of it.
Yeah, man. And the weight of the honey is in grams and not liters.
Liters, yeah.
right? So if you research, if you Google it, it will tell you that the mass of honey, it don't talk about liters as liquid because it's considered solid. So it is in grams. So the weight of the honey is in grams. So, but the reverse of this is true though. If I put my syrup in the cup first and then pour water on it, do I need to stir it?
Not much, sir.
You don't need to stir it, none at all. Because you pouring water on it is automatically mixing it. But if you do it the other way around, you have to stir.
So
Try
I
it for
stir it
me.
either way.
Say it again.
I will
I
stir it
stir it
either
either
way.
way. Like still have
Yeah,
it, still have a
same.
taste.
Yeah, same thing.
But I want you to try it though. I want you to try that basic. Anybody have syrup at home?
Yes, sir. Right now.
God Jesus. Karel, you know say you're a foodie, you know. You're a foodie. All right, Karel. I want you to do something very quickly for me, Karel. Just for we ask you to listen. We're not asking you, Karel, to drink a belly full. What I want you to do, Karel, is to take a little bit of syrup, tubes of syrup, and put in a container and then just put some water on it and drink it and tell me if it was sweet enough. If you think you had to stir it, and then I want you to do it the other way around. Put the water and then the syrup and see what happens. Quick and fast. We're waiting on you.
Right now, sir.
Right now.
We can do it in our cup.
Yeah, man. And if anybody else has it, you got man. We're waiting on you, you know. If you can carry the device with you so you can hear we are talk, please. And if anybody else has it, I want you to try it for me, please.
All right, so I'll be back. Unfortunately, I can't carry the device with me.
All right, then. Quick and fast, then. Hurry and come.
Okay.
So that like me know, man. Carry in Craven. No, man. Trust me.
So she will want the syrup, man. That's why she run go.
So she never hesitate?
Will want the syrup.
Well want the syrup, man. Well want the syrup. I wonder if a pure bulk syrup she have.
So sorry, since honey is considered a solid, what would oobleck be considered?
What? Who? What?
Oobleck? You're not aware of oobleck?
What is that, miss?
Oh, I think it's when you mix cornstarch and water. When you apply pressure, it acts as a solid, but when you pour it, it runs like liquid.
Yeah, more than likely it's going to be the same thing as a honey.
Honey. Oh.
And when you use that, the no, miss?
I don't know, just something. So I thought you'd be aware because everyone was talking about it a couple years. So
No, but
this liquid appears as a solid.
Right, I know when you mix this cornstarch, and I see that, but I didn't know that. Where's it name? Ooblex?
Oobleck. OOBLECK.
Okay. Yeah, but it would be considered.
Sir?
Yes, please.
Hello?
We hear you, man. All of we hear you.
Yes, sir. So the way I did it the first way, when I pour the syrup in it first and then pour the I pour the syrup first and I pour the water on it. And it still tasted sweet. I didn't mix it or anything. So it still tasted how it was supposed to taste. And then I did the other way. I pour the water first and then pour the syrup. And that it actually tasted fresher than
absolutely.
I didn't mix it. So it actually tasted fresher than the first time because as I said, the syrup it's going to settle a little bit at the bottom.
Very good. And that's exactly what happened. So one is more dense than the other. The syrup is going to be more dense, so it sinks to the bottom. Now, when you put the water on the syrup, what it is that you're doing, you're actually mixing. So that's why I'm saying you have automatic mixing taking place here. So you really don't need to mix it again.
But no, in Jamaicans, we're gonna mix everything.
Yeah, man. So it's different from when you have the sky juice, you know. So when you have the sky juice, you know, so you put your sheer ice in the bag. By the way, them still sell sky juice? Anyhow, you put your sheer ice into the bag. And then now what the man do is put the syrup on it and then put the water. But sometimes because the ice is there, it acts as a barrier. So it's not fully sweet. So what you normally do now is just put the straw in there and just start blow bubbles. Because you're
Yes,
blowing bubbles in
sir.
there now. It's just got to be same. If you never did know about that, Karel, something would have wrong.
Sir, but I think like bartenders do that too as well, you know, like with those mixology type people probably mixing,
Absolutely.
they probably do that first and then put the water to mix it.
Oh,
Instead.
absolutely. Yeah. So it's all a part of the game. All right. Very good. So so you don't have to mix it. That's that. And thanks, Carol, for just confirming. And the rest of you, when you get some syrup, you can try it. And it also works with honey. The honey you may still need to mix all the honey because the honey, well, it depends on the grade of honey that you get, right? Because the honey is still considered, even though it flows, it's still considered as solid, so you still have to mix. All right. Now, so a liquid to a gas is
Boiling.
boiling. And a gas to a solid is
Deposition.
deposition.
What is
Good.
it?
Sublimation. What is
No,
what?
man, a deposition. So when you move
Or
from a gas,
deposition.
right, from a gas directly to a solid, and you're going to see the lab that I'm going to do. It's well, you're not going to see it, you know. Yeah, when I explain it, you'll see it. You'll understand it. You're not going to see the lab. I can do something that I can show a video of it. I think I have it here, but I'm not going to show you just yet. And then a gas to a liquid.
Condensation.
Condensation. Mm-hmm. And gas to a gas?
Not
Yes.
Okay. All right. No, I want you to go to the plasma, right? But yes, so that's what happens.
Sir,
Yes,
hold
sir.
on, sir. Someone come to mind because it's about me. All right, so the solid to solid transformation. Is it like when you apply pressure to something and it actually changes its form?
Not necessarily.
Because that's the only way we kind of see that happening.
All right. So for example, molasses too can be in the same light as
As honey.
honey. You follow me?
Yeah.
Right. And when you do mix it, you will have a different transformation that takes place.
Okay.
Another example of solid to solid would be gravel and cement. Isn't cement a solid?
Yeah, okay, that's a good one. Yeah.
Yeah, man, you have gravel and cement one. Yeah. And when you put gravel and cement, only putting something they say no, that belows. And of course, this is before you add water to it. You can have, yeah. What about mixtures of fertilizers? You have
Like
those,
solid to liquid.
no man, solid to solid. Right? You have, the truth is, sometimes you're looking at your leaves and you're testing to see, one aspect of a geologist or environmentalist is that you can take a sample of your soil and you can go into the laboratory and test to see if the soil is actually acidic or alkaline. So it is that you can know the treatment of the soil. So if the soil is acidic, you will know use things that call like slake lime to neutralize it so it does not become it is not as acidic as it is. Because if you have an acidic soil, it means that whenever you add water to it, you're going to have a slightly acidic solution, which is going to cause the roots to rot and the plants are going to die. You follow me?
Yes, sir.
Mm. So you can, so the point I'm making is when you do the necessary test, you can do the test in a way to see if it needs nitrogen or potassium or nitrogen and something else. And what it is that you're doing, you're mixing solid fertilizers because it may have enough of one, but a little bit of something else. So you're actually mixing solid fertilizers. So that's an example of solid to solid transformation.
Okay, sir. Thanks for that. It's literally about being like, I'm so what is this?
Yeah, man, it can happen, man. It really can happen. You can have that sort of thing taking place. And there are so many other examples there, you know, in terms of solid to solid. You have many examples of the solid to solid, man. All right. Any questions following so far?
Yes, sir, we're following.
Yes, sir. Following.
No question.
All right, cool. All right, now, so I spoke to you about, we're looking at some of the characteristics of this state of matter, as you can understand. We're looking at the characteristics, you know, the solid, the liquid, and the gases. And when we look at, hold on 1 minute, hold on. Yeah, so we're looking at the characteristics. What are the things that I want to look at now? Even though we hinted at it earlier, I want us to look at the effect of heat on the states of matter. We need to look at the effect of heat. Now, let me ask you, what do you think happens when I heat a solid?
It vibrates faster.
Okay,
It expands.
very good. What else?
It gets hot.
Mm-hmm. And what else happened?
Milk.
Sometimes the color change.
It melts? Yeah, it melts, don't?
Yes, sir.
Mm-hmm. What else?
Like a ruler, or a plastic ruler.
Mm-hmm. What else?
It can break apart.
Okay, you have the separation. Okay, what else? Anything else? All right.
There's
You
more
did.
kinetic energy.
There's more kinetic energy. All right. All right. You hit most of the points in it. So the effect on heat on my solids, it expands slightly as the temperature increases. It melts eventually. Eventually, it's going to melt. Often with a small increase in volume. And the temperature remains constant until all the solids turn to a liquid. And then it says the rate of the fusion is very slow. Uh-oh, sir, using a word I don't know. Diffusion. What is diffusion?
The distribution of is gases.
Mm-hmm. But do you have diffusion in liquids too?
From an area of high, from high to low.
High concentration to low.
Very good. From a region of high concentration to a region of low concentration. Yeah, very important because remember I started off with an example that if one farts, eventually somebody who comes into that room is going to say, what is happening here? Somebody do something. Because it would have diffused in the in the space that it was released. Put it this way. If I enter a room, I enter this classroom, physical classroom, you're gonna say, yeah man, somebody just step in, because even if your head is down,
You can
you're going
smell
to
the
look up,
cologne.
you're going to smell the cologne, because it is going to be moving from a region of
Mhm.
high concentration to that of a low concentration. Right? It's going to be moving from a region of high concentration to that of a low concentration. And so this is how you're going to know that somebody enters a particular room. One of the things that I'm seeing now, everybody nowadays is taking the title of Mr. Smell Good and Miss Smell Good. Everybody is a pro on cologne, and who now spend $30,000 buy a bottle of cologne when they carry $30,000 come give me here. Them now say nothing. You understand? Because everybody have to be Mr. Smell Good. And one of the things that I'm seeing now in social media is that people are wearing a kaleidoscope of cologne. So then put on 2, 3 different types of cologne and step out.
Yeah, because you can mix them and it creates certain scents that them I do.
Yeah, but I'm saying to myself, why? Why comes? It's, I don't know. But it is just what I'm seeing in social media. Go ahead.
No, Carl, we carry the 30 grand come do it, Carl look like Carl guilty.
Who tell you that?
If it,
So you have
if it,
cheap cologne will still last longer than some of them expensive ones. So you
And
think
not
with
just
30
last
grand is
longer, but some of
crazy.
them smell better.
Exactly. 30 grand? That's how much things you can buy for that.
I have a
Me kind of guilty, but me never spend so much.
okay, I
Spend
have a
like a
student.
20.
We
What?
guilty. We
20?
guilty.
You could have
Yep,
given me.
I'm
One of
guilty.
the first batch of environmental studies student, one of the students from the group, um, called it a name when I was teaching it in class. Him say, left me a gate. You know what that mean?
No, sir, what I mean?
So him say one day him go buy one cologne from somebody who pass and I sell the cologne. And him say him smell the cologne and I say, no man, the cologne that smell nice. Him say, how much? And the price of the man charge him say, no man, that cheap money this man. And him wrong about it. And him say him put on the cologne and cologne smell nice. Him say by the time him reach the gate, him not have nothing because it evaporate out upon him.
God.
You know what the man them do? The man them buy the concentrate of the cologne. And
I know it with alcohol.
when them walk around in the community and I say, yeah, when the cologne bottle, empty cologne bottle, empty cologne bottle. That's what them do. Them buy the cologne bottle. And if them see Eternity and them see Polio and them see Gucci and them see all of them something there, them go get the scent of those and put 2 drops inside there and fill it with alcohol. And by the time you reach the gate, the alcohol evaporate off. So does the smell. Same call it left me a gate. Right? So if the man them out there using the chemistry, you too can use it. Don't make the man them have an edge over you. All right. So the rate of diffusion is very slow in the solid. All right. Let us look now at the liquids. It expands as temperature rises. It boils eventually with a big increase in volume. The temperature remains constant during boiling until all the liquid is turned to gas. What is the rate of diffusion? It's very slow. Everybody see
Slow,
what is
not
happening?
very slow, sir.
It's slow.
Slow, but it's not very slow.
Not very slow, but slow.
Yes, sir.
All right. Because very slow is a solid, right?
Yes, sir, the solid.
Right. Very slow is a solid. Correct. So it expands slightly and it comes to a boil eventually. The volume increases also. You notice, and you may wonder if the volume increase. if you have a kettle and you fill, if you, okay, you notice they have a thing to say that maximum line for the kettle.
No, sir, my kettle.
Yeah, man.
In a
Yeah,
point
man.
where
Maximum
you're
line.
supposed to just the water supposed to go
You're not
and you're not
supposed to
supposed to
pass it.
Yeah.
pass it.
You're
Yeah,
not supposed
cause
to pass it.
Yeah, man.
Why?
When
because
it
the
boil, it
water go
boil
boil
over.
over.
Why?
Cause the heat, there's a that we don't
Expand.
know.
It starts to
Yeah,
expand. The liquid starts to expand.
So the word there expands. So for example, if you're ironing and you put in water and you steam in your clothes and you put water in the iron, it says to your maximum line. Because as that water in the iron becomes hot, it starts to expand. And it may come out, overflow, and God forbids if you are ironing a white shirt or something that is white, it's going to come out and spot up your clothes. I can
Yeah.
tell you I've been guilty of that. All right. So when it says maximum line, leave it as a maximum line because you get yourself into trouble. Follow?
yes, sir.
Yes, sir.
And gases now, whoa, it expands considerably at constant pressure. And the rate of diffusion is going to be rapid. It's going to be rapid. Carol did something a while ago, and I want to come back to it. She said, "Sir, I did it two ways. I went ahead first and put the syrup in the water in a cup, and then I poured water to it. And when I tasted it, it was sweet. I didn't have to stir. And she said, sir, what I did next was to put some water in a cup. And then when I put the water in the cup, I poured the syrup there and I tasted it and I recognized that I needed to stir. What do you think will happen if Carol did the second option, placed the water in the cup first, then the syrup after, and left it for a while? What do you think will happen?
You will diffuse.
Very
Will
good.
automatically mix. Yeah.
Very good. It will diffuse. It will diffuse, but it will do so very slowly. So it will take some time for the diffusion to take place, but it's going to be done very slow or slowly. Fair enough?
Yes, sir.
All right, I'm going to pause right here and ask, are you following? Are there any questions? What it is that you um, thinking? Are you okay? Is it too much information in one
Yes.
class?
No, it's okay so far,
It's
sir.
okay. Yeah, man, it's okay.
Okay, so I'm just going to do one more thing with you. Because at the start of next class, I want to do a little lab, an online lab. Oh Lord, help me, Jesus. I'll have to go and research what it is that I want to do so I can actually demonstrate it to you in class. I am sure going forward, you are going to now see chemistry in action because everything you're going to be doing now, you're going to be looking for the chemistry in it. And especially as they talk about the environment, yeah, man, you're going to look for the chemistry in it. Evaporation occurs at the surface of a liquid, but boiling occurs throughout the liquid. Evaporation takes place at the surface. You can't evaporate something in the middle. It is going to be taking place at the surface. All right? But boiling is going to take place throughout the liquid. right throughout the liquid, you can have boiling taking place. Does that make sense?
Yes, sir.
Yes, sir.
Can you just sit back and just imagine that happening based on you putting on some water to boil already?
That's
When the
what I
water
was thinking about. Yeah.
Yeah, man. Yeah, man. You have to internalize some of them something, you know. Because when water boil, you know, when you're looking at, especially when you want to put in the flour, because you go run a little one boat, right? Carol know lots about this. And when you're looking at the bottom of the pot, you see like a bubbles forming, don't it?
Yes, sir.
Yes, yes,
And then
sir.
them little bubbles then will move from the bottom of the pot right up to the surface.
Yeah.
Yeah. So it's taking place throughout the liquid. And as those bubbles burst open, what happens?
It
Yes, see
releases
the
the gas.
steam.
It releases a steam or gas. All right? And trust me, them the steam there gas can burn you, can hurt you, can kill you depending on the pressure that is built up. Because had that been like a pressure cooker with that pressure being built, and you open that pot without first releasing some of that pressure, matter of fact, I have been to somebody's place before where there is evidence of like a crater in the people them roof. So yo, what going right here, so? Oh, there was an explosion. Explodes what? Yeah, man. The um the pressure cooker. Matter of fact, there was a situation that happened. Anybody knows the taste is on Half a Tree Road, almost across from Ruthven Road.
Yeah, man, right at the stoplight.
Right at the stoplight, there's by Balmoral, not Balmoral, Cartier.
Yeah.
Everybody know what we're talking about, so?
Come on, as a pass Victoria Mutual and another.
And I got on right.
Oh,
There
yeah,
was
yeah, yeah, yeah.
there was um there was a store there that is called that was called McDonald's. And there was a store there that is called McDonald's. And years ago, what happened years ago when McDonald's wanted to come to Jamaica, the people them go to court and say, oh, them need to change for them name because them have the McDonald's name. And the Jamaicans come out and say, no, you're out of order. Look how long McDonald's is right here. So it was a family chain business. And they used to sell hot dogs and cook food, and it was a restaurant. And I don't think McDonald's did very well when it came to Jamaica years ago. It
Yeah, Burger
was
King, they buy the most.
Yeah, man. It came and it never did very well at all. And because there was a McDonald's there, it was a court case. You can go and read up the story. It was a court case, so that's it. But of course, I was one of them people that would have bought up McDonald's. So because the people them have them good name long before you come to my country, and then you want to come to my country and tell me say me must change my name to suit you. No, sir. So that couldn't work. I knew somebody who worked there, and the person was saying to me that they were they were cooking one day using a pressure cooker, and the pressure cooker exploded, and the pot itself lifted from the fire and went right through the roof. Don't underestimate gaseous pressure. Don't underestimate it. All right? No, just think about it. That pot coming back now and coming back down through that hole that it was created. And when it hit ground, the pot opened and exploded. You know, so people get hurt. A matter of fact, people were hurt inside the place. Matter of fact, let us not even go back that far. Look at the explosion that happened at Burger King in New Kingston.
Yes, sir.
Yeah.
Yeah, that one took the internet.
Yes, man. Matter of fact, I have not even heard anything about that young lady who was in hospital and needed skin grafting. Don't know if she has
Yeah,
died.
money came on, so everybody quiet now.
Yeah, man.
Yeah, never.
Because Remember how the sister came out to say how this and that, and she want our sister to get the best care and for God foreign, so forth and so on.
Yeah,
Yeah.
man.
Mhm.
9 days has passed. You don't hear nothing. I don't know if the sister is alive.
It's
I don't know
true.
if she's dead. I don't hear nothing more.
Mhm.
And I'm an avid listener of the news. And if I don't catch news in streamline, mainstream, I catch news on TikTok. Because you know TikTok carry everything, right?
Yes,
Yeah,
sir.
man.
Everything.
I
The,
don't,
the sold out no more TikTok. After sudden, them in have money.
yeah, so them say, make them go on. Them too controlling, but it's all right. Um, but the truth is, yeah, after Sunday, you may not have, but not just you, because what the news was saying today is that lots of the servers for TikTok are in the United States, and they are going to shut down the servers in the USA. So it means that some of the videos that are stored that keeps coming back on your FYP are not going to be there again. So eventually, TikTok is going to die a natural death. And
Can't believe this.
I don't like somebody who is going to be monopolizing another country's whatever because you want to show that you have power. I hate it.
Exactly.
It's just not nice. All right. But them say they are the leader of the free world and them can do anything they want to do. But it's just not nice. I don't like the sound of it. It doesn't spell well. And the truth is, if the United States come out with a, like for example, I have an X account that I am going to be deleting. And I mean I have an X account. You won't, if you go there, you won't find me because appear numbers under for me something. You won't find me at all because me just go there for go fast on people. I don't post anything. But I am in the process of deleting that account very soon because why is it that the USA is supposed to always have these stuff? And it's so God not sleep. It's what happened to Elon Musk now. Him going to go to court because of that same X, because he never disclosed him purchased more than 5% interest. And now it is saying that he purchased this thing 150 so $150 million less than what he got it for. All right. So God not sleep. So if TikTok goes down, X must go down too. I'm sorry. All right. Um, but yeah, it is exactly what happened like at Burger King with that explosion. So if you have gas particles, if you turn on your gas in your house, for argument's sake, the gas is going to expand um considerably at a constant pressure. It's going to expand, and if when the gas expands, I say, geez, some piece, I would turn on the gas or not, come on, and you don't allow those gas particles to diffuse. You open the door and make the gas particles escape. But instead, you decide that you're going to strike a match. Remember, say you're going to go 6'6". Remember, because the gas particles in there are going to explode. Do you know that? You may not know, but there was an explosion years ago at the flour mill.
No, we never know what
I was at Exeter the day when it happened. And we heard, I was in a class teaching. A matter of fact, I was in a chemistry class teaching. And we heard the explosion. I was like, what on earth is that? It was a massive explosion. You
Yeah,
know what
that sound
happened?
like a big explosion.
You know what happened? Flour mill, bottom side us, the gas particles are in the atmosphere. I know how the gas part or the flour particles are fine. True or false?
True. Very
Yeah,
fine.
True.
man. So the gas particles are moving in a rapid haphazard motion in the atmosphere. And somebody decides said they must going to strike a matches for the light one cigarette. And the person struck a match, and that match caught the attention of one of those gas particles that went and hit another gas particle, that went and hit another gas particle. Remember, the other happened in a millisecond, right? And it just caused a big explosion. Don't believe me? Go and research it, and then come back to class and tell us about what happened. Big explosion. So you have to be very respectful to these gases. Very, very respectful to these gases, right? If you have an aerosol can, Baygon or cologne or air freshener, whatever it is that is in aerosol that is under pressure, that is pressurized, and you have flame there and you spray that thing, it is going to cause more flames to come up. I'm not saying that you're supposed to go try it now, because it can be very deadly.
Yeah,
So
it
one has
can
to
be
be very
deadly.
careful. One has to be very,
We used
very
to do it
careful.
that way. We used to
I
do it
used to,
when we were younger.
yeah, man, I used to do it. Very deadly. Very deadly. All right, guys, I'm going to pause right here for tonight. I really hope that it was a little interesting for you, and would cause you to want to read more and to understand a little bit more. There's lots more that we have to go through as we look at the particulate nature of matter. I pretty much I don't start it. This is just the tip of the iceberg, the very tip. All right, and all is well.
Yeah, man, so far, sir.
Yes, sir.
Carol, Asia, wait, what do you think?
Good so
got
far, sir. Carol, I drink our something.
Carol, go and drink more syrup. All right, guys. All the best. I'm gonna end here. We'll talk. When is it again? Is it Tuesday or Monday? Tuesday.
Tuesday.
This is
So
my
Tuesday at 7.
Yeah.
Okay.
Have a nice night.
Thank you, sir.
Bye, sir.
Bye.
Happy weekend.
To you too, Papa.